Moving further west. In the southwest Pacific, the weather systems migrate from west to east. Low follows high, follows low in a never-ending succession. Coming across the Pacific from French Polynesia, the trade winds blow southeast and east with the occasional hiccup to the north and northwest as a front or trough passes through. These troughs, unless you're being affected by the South Pacific Convergence Zone, are usually associated with the low pressure passing to the south. The strength of the trades is dictated by the center pressure of the high passing below and the latitude of its center. 1020 center pressure high will give 15 to 20 knot trades where the high meets the intertropical low. As the center pressure increases, so do the winds along its top edge. This area of wind is the squash zone between the high pressure cell and the intertropical low, which is the general area of low pressure either side of the equator. The latitude of this squash zone is dictated by the latitude of the center of the high. For example, a high of 1030 with a center at 30 south will give us significant winds of 30 to 35 knots, from 15 south to 25 south, with the wind decreasing the further south you travel. The same high centered over the middle of New Zealand will have lower winds on its top edge, probably 20 to 25 knots, but spread over a larger belt. This high is also likely to have a larger area of little or no wind in its center. The high pressure center trends south as summer starts in New Zealand. As the high pressures migrate east, the direction of the winds change. In the trade wind belt, this variation is less pronounced, but as you travel further south and move away from the influence of the trade winds, the winds will then tend to follow the rotation of the systems, both highs and lows. Highs, of course, rotating in an anti-clockwise direction and lows clockwise in the southern hemisphere. As you travel further south, the effect and intensity of the frontal bands associated with each low are magnified. The majority of low-pressure cells during October and November migrate along under Australia and tend to pop up northeast in the Tasman Sea, then cross New Zealand and migrate to the east. All low-pressure cells will have a frontal band originating well north of the system and rotating around the eastern side of the low to its center. The closer to the low and the deeper the low center pressure will dictate how much punch it has. As the front moves through, the wind direction will change as much as 90 degrees, usually to the west and southwest with a disturbed flow following it. Rain is usually associated with the front, with clearing showers behind. The strength of the wind in this area is determined by the pressure gradient. There will also be large variations in wind strength around the rain cells. So to summarize, the more intense the high, the more wind you will get on its edge, and the punch from a frontal band is greater the closer you get to the low. We also know the wind direction around the high is going to change as the high moves through, and this is more pronounced the further south we are.